Today we're learning our last shortcut rule for taking derivatives, the chain rule. And to show you why we need the chain rule, I'm going to take a look at this derivative here. We have the derivative of 2x minus 1 quantity squared. So we haven't taken a look at any derivatives like this where we have a function kind of inside another function. We know how to take the derivative of x squared, but not a function squared. So for this one, we have actually two options right now of how we could take this derivative. The first one would be to just take 2x minus 1 times 2x minus 1, FOIL it out and find the answer there. The second way would be to think of that as a product rule, 2x minus 1 times 2x minus 1. And either of these two methods is going to work. So I'm going to do it by FOILing, just so that we see what the correct answer is for this derivative. So I'm going to take my 2x minus 1 times 2x minus 1 and just multiply it all out. So my first terms give me 4x squared. My outer terms give me negative 2x on the inner terms, and then negative 1 times negative 1 is positive 1. So this ends up being 4x squared minus 4x plus 1. And now that we've got it all multiplied out, this is a derivative that we can just do with the power rule. So this is the derivative of 4x squared minus 4x plus 1. So again, simple power rule, 4 times the derivative of x squared. 4 times 2x gives me 8x. And then derivative of minus 4x is 4. Derivative of 1 is 0. So that's our derivative. And if you decided to treat 2x minus 1 squared as a product rule, 2x minus 1 times 2x minus 1, use the product rule, you would also eventually get 8x minus 4 after you simplified. But what we want to talk about now is, what if that exponent got sort of prohibitive? So what if it was, instead of being squared, what if we needed to take the derivative of 2x minus 1 to the 153rd power? So we would all be old people by the time we got done foiling out 2x minus 1 153 times. So the chain rule gives us a way to take the derivative of something like this without having to do a bunch of algebra. But the important thing about the chain rule is that we'd be able to identify which is the inside function and which is the outside function. It's pretty easy with this one. We can see that this 2x minus 1 is the inside function, and that the 153, that exponent, is the outside function. So before I tell you what the chain rule is, I just want to take a few functions and talk about how to identify the inside function and the outside function. So what I have here are 4 functions, and all we're going to do on this slide is identify which function is the inside function and which function is the outside function. So the first one, f of x equals square root of x squared minus 4. This one's kind of easy to identify. That x squared minus 4 is inside, so the x squared minus 4 is our inside function, and then our outside function is that square root. Right? Second one, x cubed minus x plus 7 to the 50th power. Our inside function is the polynomial. And the outside function is raising things to the 50th power. So raising to the 50th power. All right, so you can see the similarities between the third one and the fourth one. This is usually the hardest one to identify, which is inside and which is outside. So the cosine of x squared, that one probably most of us would get right, that the x squared is on the inside of the cosine function. So cosine is the outside function. And then the last one, I'm going to rewrite that notation. It's the shorthand notation that I think gets confusing here. When we write cosine squared, what we really mean is the cosine function quantity squared. So when I write it like that, it's a little bit more obvious, right? That the cosine is the inside function, and that raising something to the second power is the outside function. So if you can identify what is the inside function versus the outside function, then you have won half the battle with the chain rule. All right, here's the chain rule. It says the derivative of f of g of x is equal to f prime of g of x times g prime of x. What does that all mean? All right, so I mentioned on the last slide, we really need to know what's the inside function and what's the outside function. So let's kind of track those as we go. So g of x is in the role of the inside function. You can see it's inside the parentheses of the f of x function. All right, so this says to take the derivative of that outside function. So it says take f prime, so derivative of the outside function. But look what's inside that derivative. It's g of x, not the derivative of g of x. It's g of x left alone. So this tells you to leave the inside function alone. Then after you're done with that, you multiply by the derivative of the inside function. Okay, so it's saying take the derivative of the outside function, leaving the inside function alone, then multiply by the derivative of the inside function. So let's see how this would work out with our example that we already did. We did the derivative of 2x minus 1 squared, and we got 8x minus 4 when I FOILed that all out. Okay, so again, we're going to identify the inside function, which is 2x minus 1, and the outside function. All right, so the chain rule says take the derivative of the outside function first. So when you have x squared, you know, we just bring down that square out in front and make it 2x. Well, this isn't x squared, it's some stuff squared. It's an inside function squared. So our derivative is going to be 2, like 2x. That's the derivative of the square part, but it says to leave the inside function alone, 2x minus 1. And then it says to multiply by the derivative of the inside function. So our inside function is 2x minus 1. We're going to take the derivative of that and multiply after we're all done. So let's take the derivative of the outside function, leave the inside function alone, multiply by the derivative of the inside function. So let's just check this one to see if we get the same answer we did before. I've got a 2 on either side of those parentheses, so I'm going to combine those into a 4 out front. And then if we distribute the 4 through the parentheses, we get 8x minus 4. And that's the same answer that we got by multiplying it out. So the power of the chain rule is that we could also take that other derivative that I said, what if it was derivative of 2x minus 1 to the 153rd power? The cool thing about the chain rule is that this derivative in green is no harder than it was for the one that was being squared, right? It would say, take the derivative of the outside function, that 153, subtract 1 power rule to the 152, take the derivative of the outside function, leave the inside function alone, so we would leave the 2x minus 1 alone, then multiply by the derivative of the inside function. So that was no harder than taking the derivative of 2x minus 1 squared. We would just have to multiply 153 by 2, so that'd be 306. So we'd have 306 times 2x minus 1 to the 152 power, and it has saved us needing to FOIL something out 153 times. Let's try one more in this video. X cubed minus 3x plus 2 raised to the 15th power. Again, it's all about identifying the inside function and the outside function. So my inside function is going to be this x cubed minus 3x plus 2. My outside function is going to be raising stuff to the 15th power. So parentheses to the 15th. And again, our chain rule says take the derivative of that outside function, the pink function, first. So the derivative of raising something to the 15th power by the power rule, we bring down the 15 to the 14th power. Okay, that's the derivative of the outside function. We're going to leave the inside function alone at first. So I'm going to leave this alone, x cubed minus 3x plus 2. So we don't take that derivative until we're all done with this part. We took the derivative of the outside function, leave the inside function alone, then we multiply by the derivative of the inside function. So the derivative of the inside function would be 3x squared minus 3. We need to multiply all of that by our previous work. So we're going to put a set of parentheses around that. All right. And there's really not much simplifying to do here. I could pull that first set of parentheses up by the 15. So 3x squared minus 3 and x cubed minus 3x plus 2 to the 14th. This is probably all the simplification I'm going to do here. It's general convention when you have a lot of factors going on that you put the lower exponent to the higher exponent left to right. It's just convention. It wouldn't really be wrong to leave it the way I had it on the pink and blue line.